A car of mass 1,000 kilograms tows a caravan of mass 600 kilograms along a straight, horizontal road. The resistances on the car and caravan are proportional to their masses. We want to draw a diagram to model this situation, so we draw a horizontal road. On the road we will place a car of mass 1,000 kilograms, and we would assume that this car is a particle. The caravan also would be drawn and would also be assumed to be a particle. They would be connected by a tow bar, and the tow bar would be assumed to be a rod and would also be assumed to be light, i.e. have no weight, and in practice it would have very little weight compared to the car and the caravan, so this is a good modelling assumption, and also would be assumed to be inextensible, i.e. it will not stretch when different forces are applied to it. The engine of the car would produce a driving force which we'll call F. A difficult thing to model are the resistances on the car and caravan being proportional to their masses. If they're proportional to the masses, then we must have a constant of proportionality. So the resistance on the car would be 1000 K, where K is the constant of proportionality, some number. The resistance on the caravan would be 600 times the same constant of proportionality. In this situation, it doesn't matter whether the road is assumed to be smooth or rough, because the resistances on the car and caravan are dealt with by our modelling assumption that the resistances are proportional to the masses. This resistance will include both frictional resistances and air resistance. As mentioned, the tow bar would be assumed to be a rod. Like strings, if they're in tension, the tension can be assumed to work in both directions. Imagine that you and I are both holding the ends of a rope. If we both pull, then your end of the rope is going to pull you towards me, and my end is going to pull me towards you. So the tension acts in both directions. Within the rod itself here, the two directions cancel out. But if we consider the caravan by itself, we assume the tension pulls it towards the right. And if we consider the car by itself, the tension would pull to the left. As you work through this course, much of what is discussed in this chapter will make more sense when applied to the different situations that we meet.